All right, it's time to get radical looking at some square root functions. Okay, so obviously a square root function contains the square root of our variable, right? We had quadratics where we took our variable squared. We had exponential where we actually had the variable as an exponent. Okay, so now we're going to look at our variable in a square root and see what happens. Okay, so same thing, graphing, we need to make a table. XY table, so we have some points to graph. So let's decide what kind of x values do we want to choose. Well, let's kind of go with what we did for the exponential. Let's pick some negatives, pick some positives. So I'll start here, 1, 2. And I'm going to start by plugging in when x is -2. Let's see what happens. So I'm going to plug in this one right here. So y equals the square root of -2. Oh, I think we ran into a problem. If you try typing this into the calculator, you can't take a square root of a negative number, right? Because there's no number times itself is going to give a negative. Okay, because any number times itself has to be a positive, whether it's a positive times a positive or a negative times a negative. So I can't do this. So that means I can't pick a negative x value to plug in here. So this won't work if I plug in. -1 won't work if I plug in. Will 0 work? Let's test that one out. See if we can test 0. I plug in a 0 for x, and I get square root of 0 is 0. That one works out. So I can graph that one. 0, 0. Now let's go ahead and let's plug in a 1 for x. The square root of 1 is 1. So 1, 1. So 1, 1. There we go. Okay. And I can also do when x is 2. So then y equals the square root of 2, which gives me a decimal of about 1.4. So that one's kind of a gross one to graph. 2 and 1.4. 1.4, almost halfway up. So instead of picking these negative ones, I could just go, 0, 1, 2, 3, 4 or something. Or it might be a good idea is maybe pick perfect squares. Are numbers that I know are going to square root nicely. So I also could have picked, for example, I could have picked 4. I could have picked 9. Those would be nice and easy to use, right? Because let me do 4. Y equals the square root of 4. That gives me 2. So 4, 2. And if I do 9, y equals the square root of 9, 3. So those are kind of nice to use. So you go 4, 2. And 9, 3. Okay, and it's just going to keep going in that direction. So it's kind of exponential. But it almost flattens out a little bit. It's going to keep going. I shouldn't flatten this out that much. Okay, because it's going to keep going up and up and up and up and up. But it's just going to be very slow, a slow incline there. Okay? And if you look, it's not going to, I shouldn't have an arrow on this left side. I do not want to draw an arrow over here, because I can't use a negative x value, right? We just talked about that. I can't take a square root of a negative. So that's my graph. So if I wanted to state the domain and the range of this, the domain would be my x values, right? Well, we just talked about I can't use a negative, so all my x's have to be greater than 0. They have to be greater than 0, right? All my x's greater than 0. For my range, my y's in this case, well, none of them are below 0, right? So they all have to be greater than 0 as well in this case. Because this is going to keep increasing forever and ever and ever. Okay, it's going to be slow, but it's going to keep going. So there we go. So our square root functions are only going to be going one way, and they'll always have kind of like a starting point. In this case, it was at the origin. Okay, so let's take a look at another example. Now this might not always be the case. I might be able to pick some negative x values sometimes. And let's see when that happens. For example, this one right here. It tells me to graph the function, compare it to the parent graph. Well, the parent graph is what we just did. Y equals the square root of x. And if I'm going to graph that one, 0, 0, 1, 1, 4, 2, 9, 3, I'll compare it to this one right here, right? And then it says state the domain and range. Okay, so if I'm looking here, I want to pick about 5 values for x. Well, I can pick some negatives here, can't I? Because if I look, the smallest value inside the radical, can be a 0, right? I can't have any negatives. Well, to make that 0, I could give x to be a -5, can't I? Right? -5 plus 5 inside of here. If I put a -5 in there, -5 plus 5 is 0. So that'd be the smallest x value I can pick. If I pick -6, it won't work. If I put a -6 in there, now I end up with -1, and I can't do that. Okay, so -5 is the smallest x value I can pick. Then I could pick -4. Let's start with those two right away. Okay, so I plug in -5. I get y equals -2 times the square root of -5 plus 5, which is 0. So that's 0. So -2 times 0 is 0. So -5, 0. There's a different color with this. 2, 4, 5, 0. Okay. Let's do the next one. Y equals -2 times -4 plus 5. I'm going to write this one out actually. So we get, I got to do what's inside the radical first. The square root of 1 is 1. So -2 times 1 is -2. So -4, -2. -4, -2. Oh, this one's going to be doing something different, isn't it? Okay, let's erase those. Now let's think about what I want to pick next. I could pick -3 for x, okay, but I'm going to get a decimal, aren't I? Maybe I want what's inside of here to end up being a perfect square. Like get this to be 4 inside of here. And to make that 4, I could put a -1 in for x, couldn't I? Okay, and my next perfect square is 9. So what would I put in for x? Looks like a +4. Okay, so maybe pick some perfect squares, you know, like your 1, your 4, your 9, things like that. And that's all what I want to be inside of this square root. So sometimes those will help. You don't have to, you can use decimals, but it just doesn't look as nice. Okay, so I'm going to pick -1. So I got y equals -2. -1 plus 5 is 4. So I got -2 times 2, which is -4. So -1, -4. Put it right there. And finally, let's do my 4. So y equals -2. And 4 plus 5 is 9. And the square root of 9 is 3. And so I get y equals -6. So 4, -6. 4, 2, 4, down 6. So if I look, you need to graph at least 4 points to see how this thing is going, to know how to draw your curve. And if you look at it, here was my starting point, right? At -5, 0. I can't go any further left than that, because if I pick -6, now I'm taking the square root of a negative. And it's starting down, and it's starting to level out a little bit, but it's going like that. That's a lot different than our parent graph, isn't it? So let's state our domain. Well, let's compare right away. Well, first of all, what do you think this negative right here is going to do to it? Right? It flipped it over the x-axis, didn't it? Just like our quadratic. So compare it. It got reflected over the x-axis. What else happened here? What else happened? What's inside of here? This +5 inside of there? Didn't it move our starting point 5 places to the left? So it translated or moved 5 units left. And then I'm guessing this 2 value right here, this 2 value had to have done something too. Remember our quadratics? If I had a 2 there, it stretched it, it skinnied this. In this case, it almost kind of widens it, it extends it. So it basically dilated it, it extended it, extended by a scale of 2. Right, it's getting bigger faster compared to our original graph. And then if we state the domain and range of our new graph here, well, our domain, I can't use any units left in -5, right? So all my x units have to be greater than -5. And for my range, now nothing is in the positives, is it? So my y has to be less than 0. And in this case, I screwed up. I got to say greater than or equal to, right? And y is less than or, because I'm including -5 and 0. So I screwed up on this last one. I got to say greater than or equal to and greater than or equal to, right? Because we're counting that point. we're counting that point. So y is greater than or equal to -5, and y is less than or equal to 0. Okay, so just make sure, be cautious of what you pick for your x values. Just remember that you can't have a negative inside the square root, right? You can't have a negative number in there. Can't do that when you pick your x values. That's all you got to look out for. All right, there you go. You got about 6 problems to graph. Good luck. Deuces.